So here is the Composite Laminate Design Toolkit that I created. As you can see here, we have a user guide that walks you through the process step by step, showing how to calculate the failure criteria for a composite laminate. Here we have the material database, which contains different materials. The material we're going to use today is the second one. The ply stacking input is where you build your composite laminate. As you can see here, I'm creating a laminate at random. My only goal is to make it balanced. I'm not aiming for a symmetric laminate here. This is just an example. As you can see, the process is very simple, and I've also chosen a random ply thickness for this example. After creating the laminate, we can see the laminate summary, which shows the number of plies, the total thickness, and whether the laminate is balanced or not. The tool then automatically calculates the ABD matrix. As you can see here, the A, B, and D matrices of the laminate. The effective laminate properties are also calculated for the laminate we created, and these can be used in other engineering applications. Now, here is the failure criteria page where we apply a random load. As you can see, after applying the load, all the plies pass the selected failure criteria. There is no failure. In the results dashboard, we can see that the maximum failure index is only 0.15. So what happens if we increase the load in the Y direction? We can see that the failure index increases, but the laminate is still safe. However, if we continue increasing the load, failure begins to occur in the 0-degree plies because we've increased the load in the Y direction. If we look at the dashboard, we can clearly see that several plies have failed, and the laminate is now identified as failed. So what is the obvious solution? Since we want to better resist the load in the Y direction, we can increase the number of 90-degree plies in the laminate. Of course, the laminate shown here is not symmetric, but this is simply an example to demonstrate the concept. As you can see, after changing only 2 plies, the laminate becomes safe again. And that's how you design a composite laminate knowing your loading.